Hello everyone! Like everyone meaning Septembronics. Yeah, good to have you from the start. Sorry for this delay. But yeah, I had to do something and I did not do it yet still. So it's possible that I have to go for a minute soon. But yeah, decided to start like that. Yeah. Uh, Today, the plan for today is to start making some audio things to adding audio things to our product because yeah, the biggest nut to crack right now is like making that whole gameplay slash game flow framework because yeah, like our game is mostly going to be story focused and so there are like a lot of things that can happen in the world because it's a open world game based in a small world, but still the world will change depending on your actions and like there are different outcomes of quests possibly, but still even if it's linear, there like can be different things that can change. For example, some NPC can be in a different place because of something you did, or there's a door to somewhere that are now open because you did something. So yeah, all that world state that changes with quests. And another thing is like saving and loading that. Because yeah, one thing is to animate something or like trigger some action. The other thing is remembering what state is like the current state. So if if you open the door, you did some stuff, you maybe went to the location, you went back to the hub, and then these doors, let's say, should be closed now. So yeah, like stuff like that we have to save and remember and like restore the correctly at every point of the game. That's a big part that I'm going to work on now, but at this point we are not sure about what we really need for the demo. So yeah, we're going probably tomorrow to sit down with Anatol and write down some example quests, and with that we will have like a pool of first ideas of stuff that can happen in the game, and I will work based on that. I will work on that gameplay framework with all those like basic game systems, so saving, loading, and etc. So yeah, there's no point in me doing that here on stream. Like I could sit and think, and you could watch me watch my brain explode. But I decided there's also still audio to do. That's a topic that's often overlooked at the beginning of the project. But yeah, in my opinion, audio is as important as all other aspects of the game. It's often like left to the last minutes of development, but it's easier if you do it from the start, because there are a lot of actions that, like most actions you do in the game, should have some kind of audio response to them, audio feedback, just like with like video feedback, and it's often hard to then like find all those little elements of the game and then add the like then play sounds when they happen. It's easier to just remember, okay, I'm doing something, then I should probably make a place to like put a sound asset so it can play. Yeah. So, but first I think I will show you how the camera system works, because I managed to finish it at least in like this iteration last week, and it works. So yeah, I can show you what I managed to do. I want to make also, like I said at the last stream, I want to make a video that like summarizes this feature and explains in a really like compact way how it works and all the like idea behind our camera system. But to do that, I want to like make a option to add a spectator camera to during gameplay, so we can have our player with his camera like doing player stuff, and also then a window or maybe a single window would be split in half, like in a split screen game, where you can steer the camera separately, or maybe camera follows the player from a different angle, so you can see like you can spectate from different angle what's going on, and this will be helpful for visualizing how camera system works, because you cannot see like all those. It's like easier if you see a camera moving on the screen, not like if you see a screen moving with the camera. But this too, I think I will figure out on my own, not during a stream. But of course, I will show you if I manage to finish it. I will show you how I've made it. So yeah, now I'll show you how that camera system looks right now. I hope it still works. So yeah, that's the usual gameplay camera. You can rotate it as you could before. You can get it closer and stuff. And yeah, now if you start the conversation, yeah, it interpolates to the overview camera shot, where it like camera focuses on both actors participating in this conversation. So yeah, you select an option, and now yeah, the camera shot changed with a cut transition, so there's no interpolation, it just switches to different camera shot, which is like called a close-up camera shot, and that focuses on a specific, like a focus point on dialogue actor. So yeah, probably like in most cases it will be just a face. There's also this animation. I don't remember if I showed you this, if it was working before, but it's like expression layer for dialogues, where you for each dialogue line you can define what's the expression for that dialogue speaker. So let's say the basic one is neutral, but if a character is excited about something or happy, you can set this certain expression, and with that you can see that portrait is changed. It's possible that if we later we will add also some maybe UI animations to that, so excited character, like I don't know, splashes with some particles dots or stuff, something like that. So it's more expressive. Just from the UI itself, I think it's important to emphasize stuff not in like both UI and 3D world. So yeah, and if I progress the dialogue, the next one, I left this camera shot how it was, but expression changed. Now next switches back to the overview with the happy expression for our player, and then it switches back to our gameplay camera with interpolation. And how it is defined in the graph, it's yeah, like that. We have our graph. Here we start our dialogue. Here we finish in two different like ways. So I think maybe it's a good idea to just not split it too much. This dialogue finish in the same way at the end, so maybe that's more manageable way to do it. And I've added to our start dialogue node, I've added a option to set camera shot. Here, if you enable this, you can define a configuration of this shot. So we can select a camera shot asset. Right now I have only two of them. One is like our generic overview camera shot, which contains both actors. One is a close-up shot, which targets a certain actor, and yes, crazy frog. And Monion is here too. Close-up which targets certain actor and focuses on a certain point of that actor. There's also a transition asset that we need to specify here. For now I've made 3 of them. One is cut, one is fade in, fade out, and one is interpolation. You've seen cut in and interpolation in action before. And there's an optional target tag which you can set when you have a close-up camera shot selected. Now I can like select what kind of actor I want to focus this close-up on. It could be player, it could be a trigger is this second dialogue speaker, so a actor that is a triggerer of the dialogue. And that's it. That's a start dialogue node. So here I just set the overview shot with interpolation transition, and then I play the first dialogue line, where I do not set any new camera shot, it just plays this line. Then if you select the first option, I set the camera shot to close up with cut transition, and our target is player. Then I don't set the camera shot when we listen to the response to what we said. And then as we speak again, I set the overview shot again, and with the finish, there's no option to set camera shot, because at least for now it will always just go back to gameplay. We could have like a need to after dialogue not return to gameplay but do some custom stuff, maybe play a cutscene or stuff something like that. So I'm sure we won't always be like interpolating back to gameplay with camera, but for now it works. So always with finished dialog, we just from the current view, from the current shot, we will interpolate to the gameplay, and it's done the same way with those options on the bottom. So yeah, that's how it works. Those shot assets look like that. So you define a shot type. I have two types, close up and overview, and there are some parameters: the rotation for pitch and yaw, distance from our target, and field of view. And it's, yeah, it looks the same. For overview, we just have a more distance from our target, because for overview there's also a target that's invisible, and that's a middle point between all dialog speakers. And the transition assets looks like that. So if you select cut, you don't see any more of parameters here, because there's no no parameter to set here. Cut is just a cut. You just switch to different camera shot. With if you select interpolate, you can set duration of that interpolation and also a curve. Curve for the interpolation. So it's not always like linear. So you can get that smooth in and out, or only out. And if you set the transition type to fade in, fade out, you have only duration. I'm not sure about that. We will need to test use cases for fade in, fade out, because maybe we would need to, I don't know, fade in quicker and fade out than fading out, and yeah, we will see. But for now, there's only a duration, so fade in has equal duration of fade out. So I just split this in half and do that this way. Yeah, so that's it. There's also a direct overview. What is this? There's also, like, because for gameplay, I defined like a pretty similar asset to define a default camera shot, but it's not exactly that, because for dialogues you can define what kind of shot type is this, and for gameplay you just like set the rotations and field of view and distance, and that's it. So I made like a different type of asset for that, so we are not confused about properties. So yeah, that's it. Now we have also this beautiful street made by Anatol. Very nice. Looks all wet. Oh yeah, and also because Anatol is going to populate our world with some 3D models and stuff, so that's exciting. And I've made him a tool that's supposed to help him with like the ground placement of like ground objects. So here you can like define models that you want to have in your path. Here I just used a cube and a cylinder. You can set the like a base scale for them. Also some randomization for position, angle, and rotation. You can define how many rows there are, and offset between those rows, and offset in like an horizontal offset. And this is cool because you can use a spline to just draw a path where you want those objects to be. Yeah, you can add a new spline point like that. So you don't need to manually place them, but also you don't need to try to like manually create this randomization. So for example, if Anatol make 4 types of tiles that he wants to place as for a ground, you don't have to like I don't know, do this randomization manually. He just defines 4 types of meshes, and they will be randomly placed. So one mesh could be cracked in some corner, one could have a different, maybe a tint to it, maybe one is like mostly disintegrated, so you have a empty space like sometimes here. Yeah, so that's another thing I did last week, and I also want to make a maybe not a tutorial, but a summary thing of this feature. So yeah, to just document and maybe point others to this solution, because I think it's nice. So yeah, let's start with audio, I think. So you can already see my notes, because as I learned Unreal Engine, I try to write down things that I learn, just so I have like a single source of information that I can come back to, and I don't need to like find the same things over and over again, because yeah, that happens a lot as you learn. You don't know what to do something, you look for it, you at least find the right answer, and then yeah, you're like, okay, nice, I did it. You don't need that information for some time, and later you might need it again, but now you don't remember how you did something, so you need to find that resource again. So yeah, I try to make those notes, so yeah, I don't have that problem. And those notes are from a course that I did for Unreal. There, like, audio there was just touched. It wasn't like audio specific course. Just yeah, it was a general programming course. Yeah. So what I have here, yeah, sound cues are assets with graphs for sounds. Like that later it can be played by gameplay logic. So I can show you how that looks. I'll make a new folder, audio, and create a new asset, sound cue. We have different assets to make here. Also, there's a meta sound package for Unreal, which is quite fresh. I hope we can learn what it is from documentation. I think it's something for like audio synthesis, so you can like have a digital synthesizer built-in engine that can like create sounds based on parameters coming from your game. I don't know if there's any game that use that, because like I think it's hard for me to find a good usage for that, because you already can affect, for example, different audio effects like filters, EQ, reverb, etc., with gameplay parameters, and this like seems like a 5 level ahead of control above that, but it's also seems to be very complicated to get something, but I don't know, maybe someone will find a use for that. Yeah, so let's create this sound cue. Let's call it SC test. And this is how it looks. It's a graph. You have some basic parameters here: a volume, pitch, class. I don't know what this does. Maybe it's like a set of basic behaviors. We have a master, music, normal attack, SFX, special attack, PSM, and voice built in. Let's see what that is. Voice. I don't like I don't see anything in those assets that is like specific, like there's anything in here, so I don't know what this is. We'll see. So maybe I'll add a questions to my note so we can I don't know where to put the notes so it doesn't let's leave it here for now. What is class in sound cue? Next, attenuation. Here attenuation is for like defining how a sound propagates in a world. So for example, maybe you can hear an explosion coming from many that is very far away from you, but you cannot hear like a shouting because of how you set up those attenuation settings. Here we have effects, number sense. Yeah, I'll have to learn how those buses and mix channels work. I don't know right now. Source effect chain. Effect bus sense. Yeah, we will have some kind of control over effects, so probably like reverb, delays, stuff like that, and maybe filters. Submix. I don't know what that is. We'll read the documentation and see. How effects work. Okay, voice management. I don't know what this is. Subtitle priority. Oh, maybe this is something for generating subtitles when this sound is playing. That's interesting. Okay, developer, blah blah blah, animation debug. Okay, so that's it. And yeah, and in here you can do different stuff. Here's output, and what you place here, like what you put in the output, is up to you. So like basic thing is, I think it was called wave player, where you can define a sound wave to play. We have some built in. Yep. So you can select it here. You can set it to loop, and yeah, and here's output. So right now it will just play this and output the sound as it is. And I guess you can do some modulation for the sound before you put it in the output. And yeah, like there's a Doppler, there's a delay, attenuation, sound class, whatever it is, random, that's probably, yeah, so here you can attach different inputs and it will output a random one of those, and that's probably a good solution for sounds that are repeated many times in a short period. So like footsteps. I don't know. There's also always like if you have a sound when you jump and there's like your character is doing some weird shout for that. It's always annoying when it's just a single shout. So yeah, it's often a good idea to make different ones where most of them are not so intense, and maybe 1 out of 7 is like really excited jump shout. So it just does not annoy you if you jump repeatedly. Yeah. So that's it. What else we have? Crossfade by distance. Volume. Distance. Okay, so this is, I think, for like lerping between two sounds based on distance from somewhere to somewhere. I'm not sure how to define this point that this distance references. But crossfade is a pretty generic term in audio, and it means like like interpolating two sounds and based on some value, like making one that you hear only one or maybe two, but with their volumes on like halved, and yeah, stuff like that. So what else we have? Delay. Yeah, I can just make define delay values here, but it's pretty basic. So I have only min and max, and I even don't know what that is. So weird. Continuous modulator. Okay, so that's probably a node which yeah, so we can write a parameter name here. And it's like for pitch, so I can name it a pitch value. And I guess during the gameplay you could set this value somewhere between 0 and 1 to like change your pitch from, I don't know, 1 to 2. And yeah, so you have that continuous change of value. And you have the same thing for volume here. So what else we have? Doppler. Okay, some basic values. looping. Okay, so here I can define either to loop indefinitely or to give it a certain amount of loops. That's cool. And yeah, I like this graph approach to sounds, because you can define some logic for each sound and you don't have to write a code in a place where you just want to play the sound and don't think about the implementation details. You can just always change them here regardless of what you have in your code. Enveloper. Okay. Yeah, so it's also like a mix tool, group control. I don't know what that is. What else we have? Major. Oh, and that's it. We don't have any parameters here. Sounds interesting. Major. Mixer. Okay, I don't understand how that works too. Okay, so the notes here are pretty basic. I thought there will be a lot more, but I think for our game it will be enough. Because yeah, the problem is like this built-in system in Unreal is there is at least something in here. Like in comparison to Unity, like it's worlds ahead, and like the alternatives are probably better, like Fmod or I don't know other. I don't remember names of other libraries for managing audio. But like they're super cool. You have a separate application for defining those sounds, and yeah, and you can do so much cool stuff in there, but they're really pricey. So yeah, that's why I will try to use this built-in solution, and I hope it will be enough. But I think so. Like I don't expect to do any crazy dynamic music things, and I think it's mostly that what separates Fmod from this, for example, because in Fmod it's like you have like this whole arrangement view. Wait, I think I'm pretty dark. So I will make my camera a bit lighter. Oops. Okay, that's better. Yeah, so in Fmod, for example, you have that whole arrangement view as you have in a normal program to create music, and there you can place like different sounds, and you can define, for example, different segments of a music track. So a verse, or something like that, and so you can, for example, make the intro play at the beginning once, then you have a loop area in the middle that loops over and over again as, for example, combat is happening, and then when combat is done, you can just move quickly to the outro of the track. Yeah, and and it's pretty, and you have much control over it, and this all can be done just by the audio engineer using Fmod application, and like he doesn't need to even go inside Unreal or Unity to implement those things, so it's pretty cool. But yeah, we'll stick to the built-in solution, at least for now. What else we have here? Modulator. Yep. Oscillator. I don't know what oscillator means, but I guess I won't be needing that. Quality level. I guess it's something that controls the quality of audio based on some like a preset value somewhere, but it's weird that it works as a node, but okay. Random, we checked that already. Sound class. Okay, so here I can override a sound class that's defined in the sound cue properties. We have a switch, so we can do different stuff based on some parameter, and wave parameter. And okay, so that's probably, I guess, we can name it somehow, maybe I don't know, maybe volume, and so we can, like, gameplay code can pass this parameter value here, and we can use this node to influence other nodes that can use those parameters, I think. Okay, so that's all the nodes. I'm getting some idea of how this... Oh, we can also play it straight from this graph, so yeah, I guess it works. And what if we do random and add some more more inputs, more sounds. Ouch, that sound is nasty. And and you hear it every time you compile a code, and that doesn't sound like a success. Oh, I think you cannot hear it at all, so let me bring back audio. Yeah, I think it should be fine now. Sorry, so yeah, this is this sound. Okay, let's have that. And here we can now test it. Yeah, and as you can see, we can see in real time what is the flow of the graph at this specific instance. So yeah, so for example, we can see that this random node is really working. We can then, let's, I don't know, add a delay to it. Delay min, delay max. Okay, so it's not a delay in a sense of audio effect, it's just a delay from playing the sound to hearing it, and the delay min is, and it's like a random value between those two. So if we set it to 0, it's instant. If we set it to 1, we will hear it after 1 second every time. And if we set it to a range from 0.1 and 1, the delay is different every time we play it. Okay, so one riddle solved. We can also set it to loop. I wonder how the loop indefinitely will work in this preview. Okay, so we'll just loop. And if we set it to loop count, we will get, yeah, it looped 5 times. Cool. So let's see what major does, but it wants like the multiple inputs, so maybe we won't see how it works without knowing what it should do. Wonder if okay, I think I will leave it like that for now. It was a good start to understand the basics. Okay, so let's see the documentation. Audio. Working with audio. Or I guess maybe would be a good idea to look for a video, and maybe that's more entertaining. So Unreal Engine audio. I don't know if there's a video. Of course there is. Sound Unreal Engine audio. Maybe. It's pretty fresh. Meta sounds, maybe we'll check that. Half an hour, so it's not a lengthy video. Oh yeah, Subway Surfers. RTX on. Okay, visualizers, sounds, from miniguns to music. Okay, maybe I'll check that meta sounds thing. Ooh, that's a lengthy one. 2 hours. Becoming an AAA audio designer. Okay, let's check those ones. That's probably a good overview. Blah, blah, blah. Okay, I'll turn off the audio and let's see.
Thank you for coming to my talk. UE Audio sounds good. I'm Aaron McLaren, the director of the audio engine and the audio tech at Epic Games. I've been at Epic for about 9 years now, a little bit less than 9 years. And I've seen the investment in audio at Epic grow significantly through that time. I was the first audio programmer dedicated to audio that Epic had ever hired. And then from that point, we now have many audio programmers, lots of technical sound designers, and people really trying to push the boundary on what's possible in audio. And so this talk is essentially a summary of what happened in 2023, some cool features that rolled out for various products that we were working on, some preview of works in progress, like an early view on some really exciting stuff we're developing, and some first look at some really cool tech coming out that you'll be able to play and interact with very soon.
Sorry, I'm going to play this on like speed.
With a sizzle reel that we're trying to do every year,
because
put together sort of cool audio highlights
I can
from
stand,
both our own projects, but also licensees,
like sitting
and also people in the
too
community,
much,
students, people
watching
just posting and making cool stuff. We'll reach
people
out and say, hey,
talk.
would you like to be put
My brain already, I rewired my brain already to be able to
in our sizzle reel?
understand
And so
what
I'll
they're
start it by
talking
saying,
about
if
and
any,
to
if any of you are
act.
listening to
Sorry
this thinking
if
like, I'm doing some cool audio stuff, just let us
if
know.
it's too fast for you.
Hopefully we'll create a process that's a little bit more streamlined than just sort of randomly throwing stuff together. But you got to start somewhere. So without further ado, this is our sizzle reel, and I'll start the talk off with that.
Blah blah blah. Very cool. Also, here we can see some audio modulation plugins. So there are some plugins. So that's why I didn't see all of the notes that I thought I will see. Okay. So we have something like so the synthesizer is probably something more advanced than I thought, and it's not only to like generate some weird sounds, but yeah, you can also do engine sounds or weapon sounds and stuff like that. Oh, that's cool. Okay, so there is like a whole sound synthesis engine inside. Yeah, but okay. But that's probably too advanced for our game. I want to keep things simple for now. So I hope they go over the basics, not only to like present these awesome features that looks cool, but you know,
while also working on tons of games
they're kind of specific.
Hopefully it was inspiring. One of the interesting things on that is the UE logo itself is actually the tone in the beginning is the sound of the UE logo, and then the visual is driven by a 2D oscilloscope off the sound, which is pretty Epic for audio. These are sort of core principles of Epic, but I think it's worth going into these in the context of audio specifically. So when we build tech, we try to think about how that tech could be make sure that the API that's at the core of what we do. We're also open, where we like the idea of people using whatever tools they want. We have obviously available for people to check out, and people should be able to use what tools they want. Whenever we come up with tech, you can pick and choose what things that we build, including audio from the earliest stage process. Doctors really pushing the boundaries are actually tech artists. So yeah, it's a big. Also kind of give you a really brief high-level overview of UE audio, what it is. So whenever we come out with a new feature, like meta sounds, which is highlighted a lot in the sizzle reel, or quartz, which allows you to do really accurate timing, like that game that was the shooter that had all the kind of musical timing on it, that was heavily using quartz. Whenever we come out with some new tech, there's a tendency in the community to be like, oh, UE audio is the quartz engine, or everything's just now meta sounds. And really, all of these new pieces of tech live in an existing constellation of features in the audio engine. So we have lots of things. It's not just meta sounds. We've got spatialization, attenuation features. There's routing of audio busing, parameter control. There's a really robust memory management system in there, so you don't even need to worry necessarily about where your memory is getting stored. We have this sort of turnkey solutions in a lot of these areas. There's a lot to go into, but this is not the scope to go into all those things, but rest assured that UE audio is a lot of features, and it's not just meta sounds. All those things, but
Some mixes enable mixing audio generated from individual sources, combined with audio buses to route. Okay, I see. So yeah, so audio buses, like you can define where a certain sound or a music exists, in like which you can route it to a certain audio bus, and then you can, for example, say maybe you have audio bus for music and audio bus for gameplay sounds. So simplest thing would be making a two sliders in options menu where you can like set the volume for them separately, and then what it does, it could just bring down the volume of the whole bus of that volume of that bus. So yeah, the audio bus for gameplay could be at 0.5 and music on 1 or something like that. Is there enable bus sense or effect chance? But I don't. Okay, maybe it's this submix. So maybe it's a submix. I don't know. We'll see. Sound concurrency management. Blah blah blah. Soundscape for ambience, audio gameplay volumes for dynamic. Okay. Audio synthesis, audio signal analysis for visualization. Okay, cool.
But rest assured that UE Audio is a lot of features.
Blah, 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 yep. I just want to check check those plugins inside Unreal so I can get an overview what we have here. Okay, audio capture, modulation. Okay, so I don't have that enabled. Motor sim. Oh, that's cool. So there's a plugin already made for vehicle engine sounds. Audio synesthesia, generating for integrating, exposing extracted audio metadata to blueprints. All right, audio gameplay core plugin, but which is not enabled. Okay, so we have a lot of audio plugins to check out. I wonder what that is. Like, audio gameplay sounds really like it could be everything, anything. Audio gameplay volume, blah blah blah, meta sounds. Complete control over audio DSP graph, generation of sound sources via sample accurate control and modulation of using audio parameters and audio events from data and blueprints. Okay. Blah blah blah, sound key templates. Okay, wonder what that is. Sound utilities. Okay, I wonder what that is. Maybe some things that maybe it's good to check it out because that could potentially contain some features that I am going to write myself for audio. Spatialization. Yep, but I think there was already one plugin for that, or maybe not. Modulation? No. Okay, so there wasn't any. Steam audio, wavetables. Okay, there are some plugins to check. I will write them down so I don't forget. There's, I think, the most interesting one is audio gameplay. There's also that spatialization. Definitely useful regardless of what you're making. Sound utilities maybe will be useful. Sound cue templates. Meta sound, yeah, that's something I know. Audio gameplay volume, Gameplay, audio modulation. Okay, so that's it. That's all the built-in plugins. Let's continue with the
And
video.
it's not just MetaSounds. So, however, MetaSounds is the exciting thing. If you are new to UE Audio, we kind of wanted to talk a little bit about what that is. So essentially, it's a high-performance audio editing environment that allows you to dynamically build DSP graphs without interacting with a programmer.
So something like sound cues, but more advanced.
That means is procedural audio becomes a core part of your sound design experience.
With no programming experience, can create sounds using a node-based interface. So it sounds like this thing, but more flashy, I guess.
As a sound designer, and also gameplay can very easily manipulate and control any aspect of your sound.
Yeah, that definitely sounds like those sound cues. I just went through.
Growing, we have a lot of interesting features that we're adding. So out of the box, it supports sample accurate timing and control, so triggers. If you don't know what that means, sample accurate means that the resolution of the event timing is at the level of a single audio sample, so 1/48,000 of a time resolution. And it supports also, your bread and butter, sample-based, like audio file-based sound design. It's essentially, in a nutshell, quite analogous to an audio shader. We have more than 100 nodes already. These are sort of features that get added. Plugins can expand on.
Mm-hmm. Yeah, and there's like some. Yeah, there are the same. Some of the nodes that are the same as we have in sound cues. So we have wave player, we have random get, which is probably the same as random in sound cue. We have a lot of different nodes that are not in sound cue. Have a delay as it was there. MIDI, we have something frequency to MIDI node quantizer. Huh, that's cool.
On them. The community is always adding more. We have a pretty robust API for you to build your own nodes if you're a coder, and we hope to see a growing community of people building and extending the capabilities of MetaSound. So we're always adding new MetaSounds. In 5.2, we added a couple we just wanted to highlight as an example that we're always adding. You always try to, when we do a new release, just check it out, see what kind of new things we're adding. So for example, somebody on the team really wanted to do a cool super oscillator. It's basically this like fat oscillator with lots of different controls to make a really thick sounding synthesizer.
Okay, I think I understand now. So it seems like the same as the sound cue, but sound cue is more like it operates on built-in effects only, and some like basic like volume or pitch. And those nodes, like they abstracting you away from the like raw sound wave data. But with MetaSounds, if I understand correctly, you can operate on this sound wave directly. So like you have an oscillator to generate sounds. You have like very like fine-tuned control with all those effects over the sound. I don't know if still, like I said, I don't think I'm going to need this control over the sound. Like I think I prefer to just make those sounds in a audio program and then just play them, so there is less like things that I can screw up and debug.
What the college is called super oscillator.
But yeah, we'll see.
There was a lot of requests for low frequency noise, so we have like a permanent noise generator, which you can use for all kinds of applications in audio. Some other low frequency noise controls, and we also have been improving our wavetable support. So wavetables are, you load up an audio file completely uncompressed in memory and can do some cool stuff with it. The wavetable itself allows you to do single period oscillations quickly and blend between them, so you could do some really interesting sounds. But coming up in the next release, well, maybe 5.3 actually, so it might have just been coming out, is better support for large audio files, so you can do things like granulate the audio file. So in this talk, we also wanted to highlight audio modulation. There's been a lot of work in this. It's an older plugin, but it's something that we found that the community doesn't quite understand. So we've got in progress, it should be coming out soon in a couple weeks, a completely robust documentation on audio modulation. But we've also added some features to make it easier to use. In a nutshell, audio modulation is essentially analogous to the patch cables that you might use in a modular system, modular synthesis system. This is my son, 5 years old, having fun randomly patching things together. The core idea is that you have modulation sources and modulation destinations. So modulation source would be literally anything. It could be blueprint, it could be an LFO, low frequency oscillator. It could be gameplay, and essentially it, excuse me.
You can see that this guy is just a like synthesizer freak on a mission to make Unreal Engine into a synthesizer
allows you to
patch.
control data arbitrarily around the audio system. So it's not within the scope of the talk to go into depth about it, but just rest assured, excuse me, it's a robust system. You can define your own parameters. It's not just volume control, it's literally any type of audio parameter. And we have support for reading from control buses and metasounds, in which case, once you have that control bus data inside a metasound, what it's actually doing can be anything. And control bus data.
So
and we have support
you
for
can
reading.
change like the basic parameters like that, or you can
From control buses and metasounds, in which case, once you have that control bus data.
And you can read that data in metasounds to use that to fine tune your audio waves like precisely with this data that you get from gameplay. So I guess that's audio modulation. So it's from gameplay code to influence parameters. Meta sound can read from that data and use it in graph. Yeah, I'm doing that kind of overview, so because there's quite a lot of like similar things, like what is the audio modulation, because the plugin, if we have already some kind of control over audio modulation without this plugin, so I like to like just get myself this overview that I can come back to at any point that I feel confused about those.
Inside a metasound, what it's actually doing can be anything. And these are just some screenshots of some of the tools and features that audio modulation has. So one of the big things that we added is more control and blueprints for creating dynamically modulation buses, applying them, and writing to them.
So we can create a control bus, which is that, I guess, use control bus to define parameters to define set of parameters for controlling audio things. That's at least that's how I understand. So yeah, we can create control buses for like setting those parameters. So we can create one. We can create control bus mix, whatever it is. Then none of the systems can directly read a control bus value. Okay. Dynamically route modulation to different destinations. Okay.
Another thing in the vein of parameter control, this was a feature added to support that really cool Fortnite modular synthesis thing that you saw in the sizzle reel.
Changes in meta sound graph. Trigger repeat, envelope float.
Essentially, in MetaSounds now, the output pins of your MetaSound can be something that you watch in Blueprint or code or anything to drive gameplay or visuals. And it's a very easy system. It's just an output pin, and you can write any data to it. It could be an envelope follower. It could be, you know, who knows what you want to write out to it. And so there's some really cool stuff that people have done with that. This is an example of how you might grab that modulation data from blueprints. Essentially, it's as easy as saying, you know, setting up a delegate when an output pin changes and then doing something relative to it.
Okay, so we have a MetaSound output subsystem, which is a target to watch output name, blah blah blah, analyzer. Okay, so we can like with this node start like listening to the output of a certain bus or something like that, the way we want. So it's here you have envelope follower, and yeah, and assign an event to it, and here every time the output changes, we can do stuff like get the value of that, what that analyzer gives us. And here, for example, it's setting a scale of some object based on this value. And here we are adding
Saying,
so
you know, modulation data from Blueprint that and it's a very easy.
Okay, so yeah, okay, so in that first graph we used this output from MetaSound graph that gives us the sound. It's the sound wave,
just an output pin,
and here we are outputting just a integer value.
Right, and so there's some really cool stuff.
And so here we are using that mono thing output, and here we are using a number of triggers. Watch output, blah, blah, blah. Yeah.
Essentially, it's as easy as saying, you know, setting up a delegate when an output pin changes and then doing something relative to it. So here's an example of one of our tech artists that we've hired to do some cool work that demo some of this work that we're doing. And this is an example of one way that you might use output watching.
They're always like, they find so many cool examples to present some features, but it's often you just like it's hard to, you know, to find solutions like that. You know, it's like, it's often as you create something, you know, the use cases for that and how to present it well, and yeah, and there are often like a few specific use cases that work best for some solutions, for some systems like that, like this. And this looks pretty cool. That's a good idea. Like they're probably reading just a pitch and or maybe we are generating a sound in MetaSound, and we are influencing like the pitch randomly over time, and in some like in some intervals we are playing those sounds with random pitches, and I think it's how it works. It just outputs this pitch value as a float or integer, and yeah, it's being read like in this example before, and it's moving those how you call it, keys, piano keys as they play. So that's cool.
See sort of connections to gameplay. So here's an example of how that
Yeah,
actually works.
exactly.
So in the meta sound graph, every note that is chosen randomly is put into an output pin.
Okay, so it's even using MIDI for that. So it generates
in the blueprint
MIDI
graph, you can
notes,
actually set up
and
the whole-
then using MIDI, we are probably changing pitch for that piano sample.
Watch. Was kind of an interesting application of the tech. So
That's cool.
this is
Like,
another demo that
I like all those not really important but cool interactions in the world. So maybe creating a piano that you can play would be cool. I don't know how it could work in our game that is top-down and stuff, but yeah, whatever.
that was done by
For
Tapes
VR,
Club,
it's
or
definitely
Patrick
cool.
Hart. He was featured in the sizzle reel from another project. This is something he did after we were building the sizzle reel that fully utilizes this output pin watching to drive visuals.
Yeah, very cool.
There's like a sort of right. Okay, so another thing that was driven and created by the team this last year for supporting the UEFN patchwork system is this idea of building meta sounds at runtime. So in the video that you saw, there was some modular synthesizers built. Those are actually all dynamically constructing meta sounds. Essentially, it's a blueprint API that allows you to arbitrarily build meta sound graphs at runtime. Essentially, you can add input pins, output pins, connect patches together in any arbitrary configuration that you can want at runtime. We can also do it in the editor. So you can actually set up scripted actions to build meta sounds dynamically at editor time. And so we're actually already using this for robust automated testing, where we can sort of execute a script and generate like 150 meta sound variations that test all kinds of different configurations of meta sounds. It could be used for mass editing, all kinds of stuff. So it's like editor time scripting, dynamically building meta sounds. This is a huge feature. Hopefully you can kind of see the value of this, but we expect it to impact almost everything in our tech. Right now, the meta sound editor itself is not using the builder API, but we plan on transitioning to that so that we can actually support building the meta sound while it's running and actually hear your changes without having to stop and recompile the meta sound. And many other things that we're finding even daily, like, oh, we can use the builder API for that. So here's a demo. This is Chris Zuko, Mixed Universe, that was in the sizzle reel. This is actually out now on Steam in early access if you want to check it out. He has a little video here demonstrating using the builder API. He was actually the first person to use it, even before we used it. He like ported it back to 5.2 because we implemented it in 5.3. He ported the whole feature back to 5.2 and integrated it, and then released it on Steam Early Access. I don't recommend that as a path for folks, but he is very clever because he immediately saw the value of how the builder API could be used as an optimization. So his tech is essentially like a sandbox music creation tool. Prior to the builder API, he would have one meta sound for all possible configurations. So it was like a mega sound. We call them mega sounds. So it was like all possible ways that you might play the sound. And he immediately refactored his stuff so that the thing that's actually built is only what the user is actually trying to build, and that's what this video kind of demonstrates. So this is the sort of edit mode. Without going into detail how this thing works, he can basically construct effects and changing the sound and all kinds of stuff. And under the hood, when a user does this, he's actually building a meta sound graph using the builder API. Here he demonstrates the editor, where he looks at the world.
Okay, this looks cool.
The world outline, and these are all the generated meta sounds. None of these were hand authored. So he made a little utility that allows you to actually grab that generated sound and export it to the content browser.
But I don't know. I just want to know how to use audio and I don't know what to like. No problem, Septembronics. You just do what you need to do, and yeah, I'll be fine. What I was saying, I hate those presentations where they just show you all those flashy examples of using the tech, but it's like, okay, but I'm not doing this game. I just like it looks cool, but this guy he just said that this guy who made that worked so hard to like use it in some beta or alpha version, and I don't want to do so complicated stuff.
This is the graph that was actually created by the game, so you can validate that.
Oh yeah, it looks cool anyway, right?
So Chris Zuko made this on his own, but we intend to make this flow more turnkey for licensees. When he did it, we internally the team were like, we should be able to do this, and he just did it. We hadn't yet done it ourselves. Again, this guy's on the cutting edge of our tech. All right, so I'm going to switch gears, talk about Unreal Editor for Fortnite.
Ooh, Fortnite.
User-generated content world. It's where we're moving here. Generally, the idea of it. Just regular Unreal Engine development. There's considerations on local client-side scripting. There's a lot of restrictions on that for security reasons. There's issues around complexity. The user base in UEFN is going to not be professional game developers, so this idea of building this really complicated thing to throw at them is probably not a good strategy. And and on top of that, when we expose a feature to UEFN, it's going to live for all of eternity. It's like backward compatibility becomes a really big question. And so we have to be really, really careful about what we roll out in UEFN. So in the current state of things, it's quite simple. If you're an expert in UE audio and you move over to UEFN, you might be like, why can't I do X, Y,
I'm really interested in that Fortnite editor, but yeah, it's like with all those fancy game maker tools. Like I already trying to learn Unreal, so yeah, it's hard for me to find an excuse to try different one because it's never like that simple. It's never like you start it and you have some things already on the screen you have to learn and see what's working and how to make anything happen.
But essentially, we've got the ability to play a sound. You can import your own audio, which sounds simple, but in the context of a metaverse, that has all kinds of implications on moderation, et cetera. And you can control mixes. That's what this mixer device is. So a mix would be like relative volumes of sounds and things. We all are also like slowly rolling out aspects of sound attenuation and spatialization control, but it's not all of our features all at once. And there's some basic connections to gameplay. We've implemented verse components, et cetera. So ironically, so that's pretty basic. Then on the other extreme is this really crazy thing called patchwork. The scope of this talk is not patchwork, but I'll just talk a little bit about it. Check out Ryan's talk on Thursday, I think, where he'll go have a big deep dive on the system and how it works. But in a nutshell, these patchworks are actually metasound graphs under the hood. And they're essentially using the Builder API to make these connections so that the user is building actual metasounds.
Okay, that's cool. That makes sense. But it's also a specific use case. Like, it's still, this guy is still like trying to tell us that we need to make our game into a modular synthesizer to make like patches that you can. It's cool that you can make a one graph and like a one like audio effect that contains a single graph, and then as you plug them together, chain them together, you connect those graphs with this API, but it's still like making a fucking synthesizer and not making a game. Like yeah, of course those games looks cool. Like it's a game where you can create your own music, and that's really cool, but very specific.
Is this metasound, and then on the right is what it would look like in patchwork. Just a couple of highlights of why
doing
this is really cool.
this in multiplayer, it's double
awesome,
cool.
So you know about music, go jump into patchwork, make some cool stuff, and it could be really popular. Reach a large number of people. But to me, the most exciting thing is that you and your friends can get together and jam in a multiple player environment, and it's really fun. Like 4 of you can go and start. You do the bass, you do the keys, you do the drums, and like before you know it, it feels like an actual. We call them synth jams. Like me and my friends, we actually get our modular synth rigs together. It's like that, but way easier and a lot more fun. And of course, everything's updated in real time. So
I would do that, but I don't have. I don't think I have anyone
with output watching and everything like that. Really cool experiences that
who would like to play with me.
Excited about this. Please go check out Potential and Power.
Like,
We're building really unique
to do some music in Fortnite.
At Epic, we're really excited about this. Please go and check out Ryan's full talk on it. So the general idea of UEFN at large is to kind of like slowly roll out, listen to the community, see what they work.
Blah 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 blah. I don't care about Fortnite.
Core dev is the UX, the UI, the widgets. What does it look like to be making sound in the Unreal Engine? And audio people love their widgets. Things just sound better when they look cool.
Why this talk, like the talk, the name of the talk, like it sounds like it's something like the general overview of the audio, but here they're just presenting those awesome features that
one of the advantages that Unreal Engine
I don't
has for
know.
audio is that it exists in the context of a world-class graphics engine. And so
I guess we'll just use documentation.
C++ API for building interfaces. And
But
so we hired a
I think
contractor
I'll
to
check
experiment. This is the same
the other
person
video
Stefan, who
too
worked on the piano thing, some other cool
later.
demos we're doing. It's like, hey Stefan, just like iterate and experiment with like building
Blah 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 blah.
envelope editing in the Unreal Engine is difficult and not great. So we want to have this.
Ooh, that's nice.
Something not a priority over other things, but it's kind of a fun.
Okay, so yeah, so like I saw there was envelope setting somewhere, and it wasn't like I think this graph for that was very hard to use. Where's enveloper? Yeah, and he's like this curve. I don't know how. Yeah, you just use it like every other curve, but here you in this widget that he shows, you can use it like the normal envelope in a audio program. So that's cool.
Sliders are really important. You gotta refresh your knobs. I'm a big fan of glowy things. So again, these are all shaders that are being driven by.
Oh, so, okay. So they're not like widgets for editor. It's like for gameplay. So it's still about making your game into a synthesizer. But it looks cool. I mean, cool that someone will have this.
That a lot of people in our community asked for was like, I want to be able to hear the meta sound at different stages of my graph. Kind of analogous if you know anything about the material editor, you can kind of see the material get ruin your speakers.
And don't get me wrong, I love games that integrates audio on a different level than games normally do. But most of the times you don't do that. But cool that they're doing it anyway.
You saw some examples earlier in the editor one step further.
But I just also I'm worried with all those very specific, very advanced tools. It's often at some point they realize. I mean, I'm talking from a perspective of Unity user. Maybe with Unreal it's different, but I think they make a very specific, very complicated and advanced feature, but then they realize that okay, there are many people like very excited about it, but still the amount of people that really use it are very small. So at some point they drop the support for it, or just like don't update it that often as before. And with those all those advanced features, bugs are like you can. There will be bugs with with advanced features like that. So yeah, so then users are left with some software that is not really proven and matured. But I don't know.
Ability to probe any audio signal in the graph. Signal, which is very useful for audio programmers to make sure things are working correctly. But you can see, you can hover over any of the output pins, and you can actually see the signal, which is very useful for audio programmers to make sure things are working correctly. But it also helps you as a sound designer to like understand
in meta sound, you can see the like the signal intensity too. Not only that signal is playing like with sound cue, you can just see that there is something playing, but I think here we have like the intensity of the signal too.
So we're really excited about it. There's some extra stuff in that space that we want, which is like pinning to the graph, like an oscilloscope view, adding oscilloscope views on non-audio data, so you can imagine seeing your control data visualized as well, and of course adding the ability to look at the spectra, the frequency distribution of your sound. The other thing is we've been working on the audio profiler. We mentioned last year in Unreal Fest, so we actually weren't able to really go deep on the audio profiler. This was our previs that we worked with UX people on that we showed last year at Unreal Fest, but I wanted to show sort of a work in progress where it is now. It's already kind of cool, and there's a bunch of features that are coming in quickly in that space, and we hope to have some cool stuff by 5.4 that we can share with people. So here's a video kind of showing that. So it's basically a new tool. We call it an audio hub, and eventually we'll be kind of building all of our stuff in this hub. So this connects to mobile devices, to console, obviously to your local editor, and you'll be able to see all of the data coming in. You'll be able to pause the data. You can see right here that he's sort of pausing and unpausing the data. It has a log built in that's already tuned for audio-related logs, so you don't have to worry about like embedding it. It's just audio right there. All the things that are relevant to you.
That's cool. Like debugging tools are always good, and Unreal is yeah, they do good debug tools for different things. I did not have a chance to use them because I did not release a Unreal game yet, and it like hardcore debugging stuff happens at the last like stages of development mostly, and then you just and at that point you learn all those crazy features of those debugging tools.
Unreal Insights. So all of the underlying code is just basically Unreal Insights hooks. And it's a
That's
custom
good to know.
Of Unreal Insight for audio, so we'll be able to actually also show
there are some tools for that.
memory usage and that kind of thing in the future. And so This isn't quite where we want to take it. You'll see in the bottom there, there's sort of a submixes thing. That's where we're going to add the ability to visualize individual submixes. So this is the oscilloscope on the master submix, but you'll be able to see real-time analysis on any submix that you want to look at. One of the things, so this was a video that we made about 2 weeks ago, so it's like actively being used right now. And the developer that's working on this shared right before Unreal Fest an update on it, which I'll show here, which is live interfacing with the actual data that's being displayed. So you can mute it and solo it and potentially control the data and kind of zero in on what's happening in the scene. So this is just demoing the muting and soloing feature that they just added. So he's got 3 sine tones, and if you don't have it filled, basically the thing that's being displayed, you can mute and solo it. So of course, once you start doing substring filtering, you can instantly mute and solo all the things that have been filtered. You can right-click and individually solo and mute individual sounds in the list that are being displayed. Apology for other applications. A lot of discussion about what the preset.
Focus on meta sounds. So maybe that's a way to learn. It seems like meta sounds is a new standard. At least it will be at some point. But it's always with new things. You don't know if they're already ready to be used in a normal project. Gameplay systems, running systems. Okay.
Flow works like what's in there right now. If you don't know per instance off of it, but there might be thousands upon thousands of meta sound instances that are using presets. So the preset editor flow is terrible. We all hate it. So one of the big things to push for is actually focus on making UX good. What does it look like to mass edit?
Okay, so UX is still something that they're working on. So maybe that's a reason to not use it right now, because next year they're going to update.
Also thinking
supposedly
like, is this input something that is intended to be overridden by the game? Is this an input
how you work with meta sounds?
What's in there now is really more or less a proof of concept. That's going to look like the basic architecture is implemented, as you can see, but there's a lot of stuff that we're going to be pushing in that direction. A lot of our licensees have talked about this desire to have a really nice audio profiler, and so that's what this work is on. And we're shipping a bunch of projects with meta sounds right now, and so in the last couple months, a lot of work has been on optimization, profiling meta sounds, making sure that there's no bottlenecks.
Nice cloud,
sure
yeah, man.
The sound designer is doing something crazy, it's on them, not because of any fundamental issue with meta sounds itself, and building tools that allow them to understand what the performance impact will be on their meta sound. If you want to spend 20% of your CPU on one sound, that's up to you, but you should know that you're doing that. There's a bunch of new gameplay systems that we're rolling out the next year. There's some really cool stuff in the space. Can't really talk a lot about it now, but there's a lot of work that I think the community will be really excited about. Long-standing issues that interact with audio parameters and setting them in mass asset management problems. And of course, we're going to keep rolling out new DSP effects processing, more optimized DSP code. And we put TBD on here because I'm sure there's some crazy new priority will pop up in 2024 that we have no idea for the community. That's our
blah 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 blah.
Rogue attempt to engage with our
upload videos, continue your work with audio to make blah blah blah. Appear to be included our next UE audio highlight reel. That's cool. That's a reason to use Unreal features, because you can be included in that highlight reel if you manage to find a good way to use those features. Maybe I'll make a screenshot to not forget. Oops, I forgot that. Oh yeah.
audio community and conferences that we're participating in.
GameSound.com.
Epic is actually sponsoring it. Please check it out. They're going to be 2 full days of UE audio talks. If you can't make it, obviously it's high probability you can't. We'll have all of the talks posted online, so check out that when they come up. And then the Audio Developers Conference, we're giving a deep dive on the audio tech. Obviously it's high probability you can't. We'll have all of the talks posted online, so check out that when they.
Okay, so there was a conference only for audio and they uploaded all the things somewhere. Maybe here. Can I sort this? Nope. Thank you, YouTube. Okay, I already tried. Oh, okay. This is from the previous year.
All right. So.
Okay, I don't see videos from this year conference. There is a playlist with all videos from previous year of this conference, but I don't see audio from this year. Maybe they will add it soon. Okay, let's finish this.
And then the Audio Developers Conference, we're giving there's a whole bunch of talks at Unreal Fest. Please check them out. I'm sure.
Blah 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 blah
See,
blah.
in the,
Okay, I didn't learn too much from that one. I think I'm going to watch this one. It's overview only on meta sounds, I think. So maybe we can learn yeah, exactly. Yeah. Yeah, these comments are exactly my thoughts, that this is just so complicated, and what you get is like generating a single sound, which is like, if you make music, you don't in general you don't generate your sound like from a sine wave and going through different like crazy modulations to get a gunshot. You record some sounds, combine them, apply filters, effects, and then you have a gunshot, for example, which you can export in different variations and import to engine and just play them randomly, and maybe apply some reverb or something based on your location and stuff like that. So yeah, still I'm not sure if that's something I want to use. Okay. Sorry, I have to go for a minute, so I'll be back. Hello, I'm back. I think we're going to watch another presentation on those meta sounds. I think I'll
Hi,
go
good morning.
over it
Get you going.
quick. Right now I'm quite sure that I won't be using them, but just to be sure about what they are.
So yeah, the target audience for this is sound designers, DIY game developers, multimedia artists, and creative technologists. But anyone really with an interest in creating interactive experiences. As I said, this is aimed at beginners, but we'll assume some basic exposure to DSP or synthesis, and so any familiarity with like sound design tools like Maximum P, Subglider, Good Data would be beneficial, but it's not essential. So a little bit about me before we start. So my name's Matt Spenlove. I've been working at the intersection about music technology and network culture for around the last 20 years. So we've got quite a lot to get through, looking at and building a monosynth. And then we'll look at is sound as process rather than sound as data. A living sound effect that can be run as computer code and can be changed in real time according to unpredictable events. Basic patches that is just created for the new project dialog world sound. Accepted all defaults and created the project that way. So inside that I have a bunch of content related to each of the slides, and to start with I've got this hello world sound. Okay, so to introduce the authoring environment, what we see on the right-hand side is our design canvas. This is where we patch together the various different nodes to create our meta sound graph. On the left-hand side, we have the members and details pane, where we can see information about the various different inputs and outputs to the system, the interfaces that we implement, and any details about the inputs and outputs is shown down the bottom here. At the top, we have the standard sort of housekeeping menus. Loading up, saving meta sounds, some properties around the meta sound itself, and the underlying source audio. As I mentioned in the previous talk, a new meta sound source will inherit a bunch of inputs and outputs. So we've got a standard on play event to trigger up the meta sound, and of course an audio output on the right-hand side of the screen. Over here. And you can see these reflected in the inputs and outputs section at the top. Click on them to get the details. So we've got a couple of nodes here on the graph.
This guy's like he's holding a laptop in his just his right hand the whole talk. That seems really uncomfortable.
Sine wave generator. It's got a number of inputs on the left-hand side.
I feel sorry for him.
On the right-hand side.
Yeah, it's maybe it's an iPad with keyboard, but still
Color-coded
doesn't look comfortable. Give him a table.
Values, green being floats, pink being audio rate, and white being control events. Okay, so I'll open and route that out to the output of the system. And again, we've got some input and output values that we can manipulate here. One of the things we might want to do is add a user interface widget to control some of these input values. So I can patch out of the attack time, drop it on the canvas, promote to graph input. Note that you sort of shift away from the primitive synthesizer chips, the only game consoles and personal computers. Alright, so the maturity of sampling technology sort of shift away from the primitive synthesizer chips, the only game consoles and personal computers. So sample-based approaches are attractive for the realistic capturing of real-world sound, the fidelity of recording, such that our ears feed our perceptual systems convincing reproductions of the source material. So before we look any further into the DSP-based procedural audio systems, let's first create a patch using a sample-based approach. So with that we use the wave player node.
Okay, yeah. So there's an option to just play wave file. That's cool.
Okay, so I've already dropped a wave player node onto the graph here.
So if meta sound does not add any performance hit by just using it, which I think it will add, it is adding, but who knows? Then I guess there is no problem in just using it right now just for playing wave files and later like adding some features or as we need them.
So we can see on the left-hand side it's got a number of inputs mostly to do with setting the source material and manipulating the playback head within that sound file and dealing with the looping parameters and the loop duration, etc. And then a number of mostly metadata outputs, but obviously a stereo output going to feed the system. And we can select, I've already got a sample selected in here, so you can change it by using this drop down. You can drag and drop on top of that. There's various different ways to kind of update that sample, but the samples were imported into the project separately. I just had a folder underneath the content directory that I used to import. So if we take a listen to that. Yeah, there you go. So sample playback 101. So one of the things we might want to do is add some variation to our sample playback. And we can do that with using a randomized get from a collection of samples. So in this patch I have a samples variable, there we go. And you can see on the left-hand side that there's 11 items in this variable array. And if I drag it out a little bit, you can see there's a number of samples that have been added, and similarly you can update them here, choose different samples. You can drag a collection in from the content browser below. So let's just play it first, actually. Listen. So what we're hearing is a number of finger click samples, one of the 11 that were imported into the project, being played at a period of 800 milliseconds. So the way this works is that the on-play event triggers the patch. That starts off a repeating trigger that will repeat every 800 milliseconds or the amount specified by this period. That feeds into a random get node, which takes in a collection of samples, selects a random sample each time it gets triggered, passes that value
Okay,
output
so
to
yeah,
the
it
wait
really does look like they said in the previous talk that it's like a material editor for sounds, because with material editor you have all those nodes that go pretty deep in like graphics effect world of shaders, and this is kind of less abstract sound cue graph. Yeah,
which is kind of where the sample is
maybe.
and then just passes on
Shit, I'm so on the edge with that. Like this looks cool. I can see already some usages for that, even if I don't want to generate like to synthesize sounds. Oh shit, that looks intimidating.
Okay, so it's a very sort of crude, like auto music concrete generator. But basically, we're just taking that idea of like using random sample selection, moving the playback head within that sample, various different loop points, messing with the loop points, and messing with a little bit of delay at the end to get that kind of effect.
Okay, that one does not interest me.
Volume, and we have to control the volume of that particular oscillator. We routed that cutoff frequency and the bandwidth.
Okay, so there are filters here, and they can be probably controlled with parameters, but I don't see like yeah, okay, so it is input. Okay, so it's probably it could be changed with gameplay code.
Okay.
Because like I didn't see any filters here. Oh yeah, or maybe they're just contained inside those effects. We'll see.
So in this updated version of the pack, let's set a ratio.
Oh my god, that's so that's so intimidating. Integrating with a game. Yes, show me.
Message sound source that we get. It sounds a little bit different, and the FM has been dialed up. I can preview it here.
Yeah, I guess you can create music like that easily with this. Like maybe not easily, but it's just a collection of bloops and bleeps, which could work for a specific kind of game, like maybe like something like Res. It's like a digital world.
You can see here's an example blueprint I created before. So we can add it into the scene, look at the details,
Okay.
and we can see, if I filter here, yeah. So there's a number of inputs that I've exposed, and if we play, we're going to manipulate these in real time.
Okay, but he's also sped up 2 times.
Highlighted first. All right. There we go.
Okay, so he got those parameters, which you can edit from inspector in actor properties. Also, I guess you can change them from code.
Obviously, we don't want to be doing this manually.
Okay.
And so what we can do is add a level sequencer to our level. We do that with the cinematic route. Okay, so you can add that actor to sequence.
Okay, you can also animate
already available to us here.
those properties with level sequencer, which is cool because you have that fine-tune control
So I'm just going to add a number of keyframes into
but I
the mixer
guess
to animate the value of the mixer.
if not with like this play, I guess you could do that also with normal effects, but it's not like this kind of drag and drop solution. You would need to make your own solution for that, I guess.
So I've had a keyframe there. We'll leave it as. Rise up.
Okay. Some curves. Okay. Okay. There's also a video from this guy about meta sounds. Maybe. Yeah. Let's see.
Hello and welcome back to another more important again. But for those of you that have never touched it before, you think it's a little bit scary. Hopefully this will. Who is going to be using meta sounds? Well, you are. What is a meta sound? Well, a meta sound, if you're familiar with the old sound cue system in Unreal, it is basically a one-to-one replacement of that, the next level up, the upgrade. It's end game shit. So when are you going to be using a meta sound? Well, I would argue that once you know how to use it, there's kind of no reason not to use a meta sound. It's sort of appropriate for every sound audio use case. Where do you find it to make it? It's in it's in sounds, meta sound source. Now, as for where we actually call these sounds from, where we kind of play them from any actor, you can do this within a function, you can do it within the event graph, or from something like an anim notify during an animation. You can spawn sound at location, or you can spawn sound attached, or you can spawn sound 2D, which means, you know, we're playing it directly through the speakers rather than kind of placing it in the world. There are these other ones that are play sound. However, I don't like to use them because they don't have an object output pin, whereas these ones here do have an object output pin. They do have this initial params thing. It's a pain in the ass. What I prefer to do is just get the sound, you know, meta sound, whatever the meta sound type is. Then from here, we can, you know, we could set a reference to it, and from there we can access anything, you know, set scalar or set float parameter, blah 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 blah. And when you're kind of using meta sounds to define the behavior of a sound, rather than, you know, the actual sound file itself, you will want to use this to set object parameter to actually send in the wave file. And one final thing to note is you can actually add an audio component. It's something that actually exists in space, and you can set the sound over here, you know, meta sound, blah 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 blah. And so it will be there when this actor is constructed, and you can also just grab a reference straight.
It's like a basic way to play audio in games. Like you can either call a sound from code and give it a specific position in world. So I guess that's something. If you fire a weapon, you don't need to create your object. Or maybe not. That's not a good. That's not the good example. But yeah, but many times you don't like placing stuff manually is not possible because stuff changes with code, and you can just play a sound directly from code in a specific position that is already calculated there. Yeah, and this way you don't have to manage additional objects on your level. You just play something, and yeah, and the other way is making this audio
off of here, so
component,
no meta sound, blah 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 blah
blah, or sound component. I don't know how it's called, and you attach a sound there, and you can, for example, make it play from the start. Make it loop. So this one is, for example, very good for stuff like some ambient sound. So maybe you have a waterfall in game which is playing all the time, the sound all the time. You just don't hear it because of the attenuation distance from this sound source. So only if you get close enough to it, you can hear it, and it's just looping over and over. Yeah.
And so it will be there when this actor is constructed, and you can also just grab a reference straight off of here. So if you're spawning like a projectile or something, and it's always going to have some, you know, arrow whooshing sound, you might want to put this on that class. However, when you do this, you will need to hit play sound to actually start it. It won't be playing by default, I believe. And finally, how does it all work? So now that we've created one, we're going to call this tutorial meta sound. I don't know if I spelled that correctly or not. So this is the meta sound graph. You can see here we've got our trigger input called on play. So this will get called when you play the sound. This is,
I guess that background is not default. He made it.
That's because nothing is hooked up to it yet. And this is the actual sound output. This is on finished. You can see it's got a warning. That's because nothing is hooked up to it yet. And this is the actual sound output. Everything needs to end up over here. You can see it's out mono because this will be a mono sound. 99% of your sounds are going to be in mono. The only things that would be in stereo are non-diegetic sounds. So user interface sounds, music that isn't in the world. Like music that's playing, inside the brain of your players. That will be in stereo. If you need it to be stereo, then you will just go to meta sound, output format, stereo. But we're going to be mono now. So the meat and potatoes of a meta sound is a wave player. Bam. Wave player, on play, play a sound, output of the audio to the output there, on finished to unfinished. Bam. We're done. We've created a meta sound. And basically all this is going to do is play a sound, blunt impact 4, when we hit the play button. And then when it finishes, it will call the unfinished event, which this is through the interface for a one-shot sound, which means when this is called, it's going to kill that sound. So the a sound there, unfinished to unfinished, bam, we're done. We've created a meta sound. And
unfinished. Okay, so wave player has those all those flow input and output pins, and you can make it start playing by plugging the on play pin. You could make it stop with some other. I guess you could define your own custom events that can trigger stuff. And yeah, there are output pins from the wave player. For example, we have unfinished that can go to unfinished output, which is, I guess, responsible for destroying the instance of this meta sound. That's so there is an additional step to just having this, because we only have output here. So we cannot make this mistake by, for example, not using unfinished, like not outputting the unfinished to the unfinished output. If you just want this, this basic audio player, unless we can maybe use this meta sound as a template and only swap different sounds on instances of that template. That would be cool, but then we lose some of that customizability per instance, but I guess that doesn't matter because you can just make a new template then. Yeah, so we'll see. I'll just write some notes to about meta sounds. It's like sound cue, but more advanced. Can be used either for playing wave files or to generate sounds. Yeah, I guess that sums up this whole plugin. I just needed this two sentences to understand. But yeah,
basically all this is going to do is play a sound, blunt impact 4, when we hit the play button. And then when it finishes, it will call the unfinished event, which this is through the interface for a one-shot sound, which means when this is called, it's going to kill.
Can you hear like I can hear a buzzing sound coming from my mic. I don't know if you can hear it too. But I don't know, whatever. Let's continue.
That sound, so it's no longer taking up any juice. So we can debug this by hitting play. How exciting. So now we're going to play. How exciting. So now we're going to be taking a look at some specific examples of what meta sounds are actually capable of. But before we do, you're going to need some sound effects. And what better way to get the exact sound effects that you want than recording them yourself? Now you're probably thinking, Charlie, I'm not, a qualified, specialized, professional audio engineer like you are. Well, what if I told you that recording high-quality audio is a skill that has been shared by the sponsor of today's video, Skillshare. Skillshare member playing cool sound variations. So, for example, it's playing a random pitch, playing a random sample. There you go, some random variation. The super basics that were kind of there by default in sound cues. Not very exciting. You're probably thinking, what the fuck? Like, what's the point of this shit? It just seems like more effort. Well, that's why I'm going to show you a few little examples of what meta sound can be used for. All right, so a few cool things. That's why I'm going to show you a few little examples of.
Okay, so yeah, that's definitely you have more fine-tuned control. Like here we have a separate random node that can be placed in different inputs of other nodes, and it's not like integrated into like take random thing from array. Yeah, so it's a bit more complicated, but I guess my audio graphs are not going to be super complicated, so maybe
be useful. All right, so a few cool things.
Maybe that's fine.
One that I was experimenting with just earlier was actually changing the sound over distance using. You can hook into the distance attenuation and spatialization interfaces. You'll see it go bang. Cool. And then if we move this all the way over to here, and we look at it from afar, you'll hear there's a tiny delay. And it's also that really echoey version of it. And so this is different from just attenuating the volume. It's also different from just attenuating, the higher frequencies or something as it gets further away. We can actually change what the sound sample is. In reality, if lightning strikes way off in the distance, you hear like all of the, the reverberations of the thunder. So when we're dealing with sounds over distances, the sound actually changes and you might want to use a different sample.
Okay, that's cool, but because it allows you to change different parameters based on the attenuation distance from sound source, but I would like to have that option to like maybe make it's not that simple. I wanted to say that I would like to have this effect applied at the end to all of my sounds, but it's not possible because at the moment the sound is like processed. You don't longer hold that information of attenuation. You just have your new wave file that you're going to play. Because what I'm saying is that's cool what he did, but if I'm supposed to recreate or copy paste this logic every time I want like basic effect like this to happen, because if I use it in one place, I probably want to use it in many places, many other places, like many other sound coming from different things in the world.
This is an example of that. So another example that I use.
That's a question of like because workflow is very important to me, like to have a good workflow that's not requiring you to use like to do the same task over and over again, and like making the workflow manageable. Because if we have the same part of the graph paste in different places, then if you change it, update it in one place, the others will not. So maybe there is something like a meta sound subgraph, so you can contain your logic in a single node that you can reuse. That would be cool. We'll see.
Meta sounds for is with our weapon whooshes. So you can hear our weapon goes, but we're actually doing this procedurally using the speed of the weapon to drive the sound. Even if I do a dodge roll, you can hear it whooshing. And because our kind of combat system is very, it's got a lot of procedural additions to it. If I turn around and attack, you can see that the sound changes and it's accurate to the speed of the weapon. Now the sample itself that I'm using for that whoosh is just literally me going into the microphone. So if we hit play, you can hear that nothing's happening. That's because we're at a value of 0 or a speed of 0, which means this is going to be 0, which means we're not going to get any sound. However, as we start to go past 800, we start to get some noise. And the further up we go, anyway, so that's essentially how that works. So the last few examples that meta sounds can be. Anyway, so that's essentially how that works.
Okay, so he's playing a sample that's looped in some specific pitch that's based on this input value, and there is also a noise generator that's multiplied and added and multiplied by some value based on that input.
So the last few examples that, you know, meta sounds can be...
That sounds cool. Sounds really cool. For
modifying
the,
sound.
it's definitely a like this kind of procedurally generated game is definitely a good fit for something like that.
In unique ways.
Because you have like with like physical animations, you have many outcomes that can happen, and if you can handle them in a generative computational way, procedural way,
for
yeah,
example,
then you have like this good kind of immersion in the
So when
world.
we hit this door, the sword goes clack. It's very, you know, a very sharp sound, but if we hit the ground, you can hear that it's kind of softened. And we just use, you know, some envelope filters for that. And then you also can just set up some pretty complex behavior with a single variable. So for example, this door only has a speed variable being fed into the meta sound, but it has, you know, a bunch of volume attenuations. It has like a procedural creaking sound, and then that can crossfade into like a looping door squeaking sample, which then also has its pitch altering as the speed increases. So for example,
Ooh.
sounds like a cow. It does, doesn't it? Anyway, that's another example of some pretty complex behavior that just gets driven from one variable. Now you're probably thinking, Charlie, why haven't you covered, you know, all of that fancy shit that they show like in the Unreal streams, where it's like, you know, procedural music and all of this crazy, you know, synthesizer-esque stuff? Honestly, I don't find that side of meta sounds very compelling. You know, I am a musician, and it still seems a little bit novel. I'm yet to see the, I guess, value in it. For, you know, obviously some projects. will
Okay,
find
so
that but the majority
I agree with
of
this guy.
projects, it kind of seems like a bit of a novelty. I think it's good to get excited about that kind of stuff. But in practice, fully procedural music isn't going to be good. However, we will look at interesting ways to implement written music using meta sound. So things like layering music, and also thinking about, you know, how we can structure our music in order to work with meta sounds. And that'll be kind of something that we touch on in most of the videos, is using meta sounds and this kind of, you know, like audio shaders style of doing audio. It kind of turns the traditional, you know, sound effects mentality on its head, because you don't have to record, you know, a billion different variations of the same sound effect. Like, for example, in our project, we don't need to record, you know, sword hitting wood, sword hitting grass, sword hitting sand, sword hitting stone, all of that stuff. We just do alterations procedurally. I think even if you're not a sound designer, or an audio engineer or a Foley artist or whatever, if you're just a coder in your project, it's still definitely worth learning this kind of stuff, because you can then pass that information onto your sound people and come up with some interesting ideas. And, you know, in the long run, it just makes things a lot more simpler, and it will save a lot of time, because, you know, you can essentially create sounds on the fly instead of needing to go and render out a bunch of different variations of shit. Anyway, rant complete. As always, if you found this educational or entertaining, make sure you press the subscribe button, like the video. If you have any questions already, then chuck them in
You
the
have
comments.
that
or chuck them
like
in
from
now.
me. Cool. Does he have more of them? More of those audio videos? Randomizing audio with meta sounds. Blah blah blah. Okay, so there are two videos. Maybe if I type meta sounds. Nope, that's the two only videos about that. So
Hello,
guys,
and
I have a quick look
welcome
at
back to
this. Maybe
5
he'll show some usage examples. That's, for me, that's most important things. Like from that previous video, I already learned so much more than from those Unreal presentation
Meta
that
sounds,
just
the show
showed some flashy things.
where we, I don't know, talk about meta sounds in we're in the meta sound graph thingo. You don't know how to get here. You'll need to go sounds, meta sound source. You've got a new meta sound. Well done. So there are kind of three main dimensions that we can randomize our sound in. Those being pitch up and down, time across this way, and the actual sample itself. So the breadth. So the first one is pitch. Now what we're going to do is we're going to start, as we do with most meta sounds, with a wave player. So we have a wave player. On play, play, sound. Let's go like, I don't know, chain, mail, 1. On finished, finish it, mono to mono. So now if we hit play, we are playing that same sound over and over again. So let's variationate this sound. The first thing we're going to do is the pitch. So on play, we're going to grab a random float value between -5 and +5. This is a pretty big number. This is in semitones. We're going to plug this into the pitch shift, and this is going to select a new number every time this is executed. So now if we have a look, there you go. Pretty simple. So that's our kind of up and down variation. The next one we're going to look at is selecting a random sample from a list. There's a few ways we could do this. One of them is by making an array variable. So this could be called our sounds. The type is going to be wave asset, and we're going to click the is array button. So now if we were to drag this in, this is an input of an array. So when we actually play this sound, we would need to set this object explicitly. Otherwise, instead of using an input, we could make a variable sound. We would need to set.
Okay, so that's cool. So it's like we don't have to. We can define a single graph with all those effects already applied for all those sounds that can share the same logic. But we can just make the specific sound asset, sound wave asset, as a input. So every time you play this meta sound, you just also give it a specific asset or set of assets in case of selecting a random one. Yeah, and you don't specify it inside the graph.
This object.
Yeah,
Explicitly.
like we did with sound cue here.
Otherwise,
So
instead of using an
that's cool.
input, we could make a variable called wave array of type wave asset is array. And this can be used as like a kind of like a static or like a preset. So let's just use this for the time being. Now you might be able to see, yeah, you can see over my head, we have this default values section. What we can do, which is very handy, what we can do is we can select multiple files and we can just drag them straight into there, and that will add them all into the array. So you can see here we've got 9 of them. Now what we will do is random get, which is just going to select a random one of these values and output it here. Then we're going to put this into the wave asset slot, and we can just put these one after the other. So this is just going to be saying on play, select a random number for the pitch variation, then out of here into the random get a random sample from this array that we've set up. Do we want any repeats? No. 1 is no. 0 is we do want to allow repeats. This basically just, it's like shuffle. So we have 9 samples in this array, and it won't repeat any of them until all of them have been repeated. So imagine we've got 9 cards and we shuffle them and then we deal them out one by one, and then when we're done, we combine them all again, shuffle them, and then deal them out, in a different order, but we never get 2 of the same card until they're all dealt. So that's basically what this no repeats thing is saying. So anyway, following the execution chain, on next, wave player, this wave asset is the chosen asset with the chosen pitch. On finished, we finish. So now if we hit play, we're getting random sample and we are getting random pitch. So the next thing we can do is randomize the kind of timing of how this is being played. This might seem a little bit roundabout, but it's so we prevent looping code. We are going to do a trigger repeat with a period of the maximum kind of time frame that we want, these sounds to kind of be randomized in. So let's go like 5 seconds. Then whenever one of these repeats is triggered, so every 5 seconds, we are going to get a random time between 0 and let's just say 4.5, because our sample goes for half a second or something, and we don't want to kind of play samples over the top of one another. And then on next, we're going to delay by this value that we've chosen. And then this will be going into our random pitch, our random sample, play it randomly. We're not going to finish it on finish because that would kill the sound too early. This will give a warning, but you can just delete it if you don't want to, or sorry, remove the interface if you wanted to like destroy it manually. So if we hit play, this will kind of just do its own thing and just play the sounds in a pretty random fashion. You know what, I'm going to speed it up a little just because it's very slow. So let's just do like a 2.5 second with a 0 to 2 second delay. So let's hit play. There we go. So you can actually see the execution pins happening visually. So you can see this trigger repeat is every 2.5 seconds spitting out an input into the random time, which then spits it straight into the trigger delay. But then you can see that this delay is delaying it by a random amount. So I hope that kind of makes sense. Now, this isn't a true kind of looping randomizer. So this is kind of just saying we have like a timeline. This is time, and we've segmented it into 2-second intervals, and each of these intervals will contain one play of the sound, but the actual position within it will be completely random. So we might get some that are close together. We might get some that are far apart, like this. Essentially, it's just kind of randomizing the timing of the sound. This might be useful for things like ambient sounds. Maybe it's like birds chirping. Maybe you've got like, you've set up some kind of piano stuff like in
Okay,
Breath
so
of the
that's
Wild, where you just play
also
random.
that would also like this trigger repeat node. I was thinking about how to implement sound of like when you see letters appear in the dialogue. You often in games hear that like, I don't know, some clicking sounds or something like when you see these letters appear. And I was thinking like, okay, I should play one sound per character, but then I realized that like they go so quickly that you don't really need to, they don't need to match 1-to-1. You can just play some sound in a specific interval, and maybe make it quicker if you skip the dialogue line. So yeah, so I guess this is pretty cool because I can just play one meta sound and like using this logic inside the meta sound itself, define how quickly they should go, and and what sound will they play, so I can also add the sound wave randomization there, or pitch randomization, and maybe add an input for the trigger repeat period. So if you skip, I change the input value, and then it will go faster.
Little piano fiddly diddly at random intervals. And the benefit of doing this all inside the meta sound is that this doesn't run on the game thread. This runs on its own thread, completely separate from all of the gameplay timers. And delays and ticks and blah, 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 blah. So that was just a short little example of how we can kind of get some random variation through meta sounds. I hope you learned a little bit more about the interface, but we will be exploring more and more complex things as this series goes on. So I hope you are looking forward to it. And as always, if you want to support this channel monetarily,
All right. Cool. I don't know. Is there any more of those things I should know about? Soundscape. What is soundscape? So it generates ambient sounds which are streamed as the player moves around the world. So mostly. Okay. I don't know what that is. Something to play ambient sounds, but somehow it manages life of those sound based on where you are as a player, I think. So nah, I don't need that. Step dialogue with different listeners and contexts. Basic dialogue setup in our engine by using meta humans as in-game characters. You will also learn how to use dialogue voice, dialogue waves, just characters' tone depending on who they are speaking to. Blah blah blah. Dialogue voice, it's some kind of object. Create asset, name Ada, gender. Yeah. Okay, so you assign those in somewhere. Ah, okay, so they're just in that variable. Building dialogue waves. From Ada to Cooper and Hannah. Needs a dialogue wave assets, I should remove it. Okay, create new dialogue wave asset, name blah blah blah. Spoken text, enter, hey, could you come over here? I need to. Yes, you need to set up two different dialogue contexts. Okay. Alright. Subtitles are by default, blah blah. Okay. Okay, so this. There is a system that is specific for dialogues, and like with this extensive system for setting dialogue context that are used to select which specific sound you are using as a dialogue line, not not useful for us, I guess. Waveform editor. Okay, that's something in beta, so maybe not for me, but it's cool that you can do stuff like that. You can trim sound waves directly in engine, add fade-ins, fade-outs, normalize sounds, that's cool too. And export the wave file to edit it later. Cool. Sound waves, importing audio files. Boring. Blah 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 blah. Yeah, you can play them. Details. Blah 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 blah. Meta sound, that's probably a big topic here, but I think meta sounds, the next generation sound sources. Ooh. Yeah, it's very good. Increased performance? Render asynchronously to the main audio mixer. Sound sources. So static non-virtual, blah blah blah. The system just interpreted bytecom runtime. Okay, so they say it's pretty optimized. So that's another reason to use it, I guess. Blah blah blah. Parameter buses. Okay. So I think I understand now what is the parameter bus. And this is probably okay. Audio modulation. Okay. So if I understand, hey, do you prefer UE4 or UE5? I did not use UE4 too much, but to be honest, when I was learning Unreal Engine, I was watching a UE4 course, even though I was at the same time I was just doing all the stuff in UE5, and it was all the same, like totally the same. The interface is in some places it's different, but most stuff is really the same. But still, like I'm using UE5, I guess, to have all those new flashy features, which I don't know if I will make so much use of them. For example, Lumen and Nanite are like they look pretty cool, but still they require a lot of computational power to run those games smoothly with them. So you still, like, if you want to support weaker hardware, you still need to create make that fallback lighting inside your scenes. So by using Lumen, you have to manage two separate lighting pipelines at the same time to support weaker hardware and stronger hardware. So I'm not sure if I'm convinced to use it because we are more into making the development easier, not harder, which Lumen does, but but by using it, it makes your player like, yeah, you have a smaller player base because not everyone will be able to play your game on their GPUs, or I don't know, with some weaker consoles. But yeah, both engines are fine. I mean, I don't have a prefer. I don't prefer one over the other. UE5 has a definitely nicer interface, and I like that workflow where you click Control plus space to bring up this content browser. You select your thing. You can, I don't know, drag something from the browser to the scene. It hides automatically. You place it. Cool. You can do something with this. Having at the same time having all the, you know, this world view that is pretty big, and yeah, that's cool because the alternative is having it docked all the time, which is, I guess, for in some situations it will be easier this way if you move a lot of files and you need to, I don't know, maybe look into 2 folders at the same time for some reason. But I like that workflow that they added to Unreal Engine 5. Yeah, I have quite some crashes, even though it's just the beginning of our project, and I don't know if that's specific to Unreal Engine 5 or Maciej Specjalski, thank you. Or it's just Unreal Engine thing that's shared between 4 and 5. Yeah. So let's continue looking through the sound documentation. Yeah, but meta sounds, I think I understand what they are and how they work. Sound cues is like, I wonder how they are, like what's the relation between sound cue and meta sound in like a class world, so in C++, because if I understand correctly, meta sound and sound cue is like basically the same thing as bass, so it's something that just plays a sound, so you can in the same place where you play a sound, you can use either one of them, and they will just behave differently because like their implementation is different. But I want to check that. So sound cue, use sound cue. Yeah, and it extends U sound base. So that's a base class for playable sound object. Yeah. And meta sound. U meta sound. Yep. U meta sound. That's not its class. U meta sound patch. Maybe that's the one. As a type is used for meta sound answer. They're going to be used as nodes in other meta sounds graphs. They contain no required inputs. Okay. So U meta sound patch is something I was talking about. I would like to have in this meta sounds workflow. So it's like a subgraph in materials. So you can create, for example, this effect of modulating, I don't know, filter based on distance from the sound and to the camera, and I can share the same effect, the same subgraph in different meta sounds. So that's cool. Something to remember, but I still did not found the meta asset itself. Maybe I will create it and I will see maybe its class is named differently. Audio meta sound source, I think that's sound patch. Okay, so that will be this subgraph. Let's call it MSS test. All right, and okay, so maybe it's meta sound source. Yeah, I'll look for that. Meta sound source .h. Where are you? Oh yeah, here. Okay, so it's extending U sound wave procedure. And if yes, are you planning on using it, or are you gonna use internal Unreal tools? I think I'm going to use those meta sounds, and they are internal Unreal tools. So two yeses for that. It's like a new flashy system for audio in Unreal. It looks kinda similar because in the old SoundQ system you also had the graph to build the specific like behavior of sound. Like you could just place anything you want to the output based on what you do here. But meta sounds go a little bit deeper. They work more like materials, so you have a lot more control over the flow of that graph and stuff. Yeah, there is a fmod for Unreal, but yeah, I already said at the beginning why I'm researching the built-in tools, because fmod costs money and we don't have money, and yeah, I prefer to use free stuff whenever I can. Of course, if fmod is worth it for some use cases, sure, but I think these tools are pretty extensive and extensive enough for us. Yeah, I wanted to check what's the base class. Okay, so it's extending U sound base as the like in this inheritance tree. So you can either use SoundQ or meta sound source, and yeah, the implementation just make them behave differently, but they are played back in the same way. You pay for it when you launch the game. Yeah, but I don't know. I prefer not to pay any money for something I may not need. Okay, so I think I've got an overview of sound system in Unreal, and over these 3 hours, I think I got convinced to use meta sounds in the end, because I was on the edge and the entire time, and I was like, no, because those presentations you weren't there when I was watching the presentations, but they were like showing all these flashy features of, I don't know, making your game into a modular synthesizer, and yeah, that looks cool and all, but I don't need that kind of features. And if that brings me a performance hit and more complicated setup, then I prefer to use a simpler tool, because we just need basic stuff like play audio, play a sound, apply some effects based on some stuff like low pass filter there, high pass filter there, and based on some stuff happening in the gameplay. But I guess it looks like meta sounds are just sound cues, but you have more notes. Basically, they are a bit more complicated, but if this, I mean, let's try. I want to see how was it called? Meta sound patchwork. MSP. Let's call it attenuation effect. Okay, so we want to play a wave play. Yeah, a wave file. We plug the input on play to trigger the wave player. Let's select a wave to play. Let's have that. It's fine. Let's leave those. Yeah. And unfinished to unfinished. Or maybe no. Let's make it. Let's make it trigger over time. Because this way I can place it inside my world and test it, how the attenuation, so the distance from the sound source to the player, changes over time. So there was this trigger repeat node. I just repeat out to play. Let's do that. I guess if it's 0, then it will be triggering in infinitely. Let's make the repeat period maybe 0.3 seconds. Fart samples. I will make them. I had some nice farts yesterday, but I forgot to record them. Sorry. I think tomorrow is the good day to record some farts. We're gonna be together here, so yeah. Double the fun, double the farts. Yeah, repeating this infinitely. And I guess I don't want to finish it. Attenuation. Oh, so there is like something like interface. Cool. So there's also a way to share the same features by adding a meta sound interface, and we have one for attenuations, and I guess I suppose it will be driven by the internal Unreal logic. Okay, cool, Maciek. I can't wait for Kapusta and Fasola. That's a perfect combination. So I can use that and do what? Okay, so here we have the asset. Can I when I should edit the sound? So because here I'm playing this wave. Here I put wave asset. Here are some like flow outputs, so I can do something at this point, but okay, out mono, it's here. So now I can apply some effects. So let's say filter, one pole, low pass filter. High pass, yeah, let's do high pass filter. Too bad there is no like visualization for that. Now let's multiply this by something. Yeah, I don't know what's the frequency. What's the, maybe I should, okay, I think I should remap this somehow. Conversions. Yeah, so that's definitely that's the difference between those two. Here I just do all those math by myself, which is cool because yeah, I can do all this stuff. But in the SoundQ workflow, I just had some very limited number of nodes, and I guess they were it was enough for most use cases, but yeah, here I can do some things that I would need to implement in C++, and like you know, getting parameters and maybe applying some different pitches or changing wave assets to use dynamically or stuff like that. But here I can like route inputs here and contain all this logic here, which is I guess better because yeah, you don't have to change the game logic too often with this. You can just, if you've made a mistake, you can change stuff here and it's quicker. Okay, yeah, but I was looking for a remap node, which is max map range, and yeah, so what's the range? 0 to 1, I guess. Out range will be so I can just multiply it, but okay, let's leave it like that. So the maximum value that we want to okay, so yeah, min and max value. Maybe let's look at how the frequency chart looks. Frequency. Is that how it's called? Chart or? I want to be sure what's the range of frequencies. Wait. I have an idea where I can find it. But anyway, shit. But anyway, yeah, so let's leave it like that. I will find later what's the range for the frequency. I want to move the filter between. So I'm applying this. To output. What if I... Okay. I don't hear any difference because I guess this I can preview those changes by dragging this, but I don't hear any difference. Let's see if I would, let's change the period because I will it's harsh. Okay, that's better. What if I plug this into pitch? Is this working? Nope. So maybe it's not. I can't preview it like that, but that would be weird. Like it's so seems so obvious. Shift. What if I multiply this by some big number and now put it in pitch shift? Oh. Okay. So I can preview it. It updates in real time. Maybe there's some effect. Maybe let's look for some effect that's easier to to set up, because I don't know what's the frequency I should use there to hear that. Stereo, blah blah blah. Dynamic filter, maybe beat crusher. Sounds crushingly good. Some beat depth, sample rate, I don't know. Maybe I should have plugged this into sample rates instead. Okay. What about 1000? Okay, and now if I place a sound source in level, where is it? Basic shapes, no. All classes maybe, sound. Audio, volume, nope. There was something like that, like, I don't know, sound actor, sound source. How was it called? Maybe audio volume. Yeah, oh, I think audio volume is for applying effects, like, you know, you could set it up so when you walk inside a cave you have a lot more reverb applied. Maybe I'll just make a normal actor and add a sound. No, audio. Yes, and here my beautiful MSS test. Yep. Blah blah blah. Effect chain. Allow specialization, override attenuation. Okay, so there is. Okay, so I can set the attenuation. Oh, I understand. So I can create attenuation template, like templates that can be shared between objects, and based on, because with attenuation we can define the inner radius, in which I think we just hear inside this sphere. We can hear this sound in like full volume and full intensity, and inside this fall off distance we like get the intensity scale down between. So if we are here at the end, we get the attenuation value of 0, and if you are somewhere inside this sphere, we get the attenuation distance of 1, and this is the value. And if it works like I think it is, it should use this value like I was testing it right here. So it based on where we are, it should change that for us. Another thing is that in top-down games there's that problem that you can either use your player character as a reference point for all these effects. So for example, if we have this sound source here, let's imagine our player is here, but our camera is here. Then even though our character is very close to the sound source, our camera is always somewhere else. And yeah, it's not so obvious where it should be, because as you rotate the camera, those sounds, I guess, should also rotate, not with the player, because if we used our player as our player rotation as a reference point for like spatial effects, so the stereo effects, then we could hear the things that are on the screen on the right side, we could hear in our left ear. So yeah, that's not so obvious. I think I should, I need to create a test actor for that too. Actor, audio test, because I need to play the sound inside in the blueprint graph. So yeah, let's do this once more. It's audio, MSS, do a Doppler effect, maybe on Wednesday, because I'm going soon. I just wanted to test that today, if that works, if that attenuation works as I think it should. So yeah, let's do that. Let's override attenuation. Let's leave those values, I think. Oh, we can also define what's the curve for attenuation. So if you are linear is like just setting the value, interpolating those values from here to here, like linear. I don't know if I can explain that to you. You just define different curves for how the values change over the distance from the source to outside. So let's play the sound on begin play. I think you do it like play. Okay. Yep. Let's remove this one. No, let's remove this one and this one. Now if I play the game, I don't hear anything. Oh no! I can hear it, but can I maybe audio? I would like to. I would like those like attenuation distances to draw their gizmos, because right now I don't know where this object is. Attenuate, whether or not I cannot still I cannot see them. Okay, but something is happening. I don't hear this bit crush effect at all, even though even with attenuation of 0 and 1, it's it's pretty noticeable. So it should, like, there's something wrong with this part of the graph. Huh. Ah, yeah, because it's a camera, I forgot. Yeah, so now it's using the camera for the reference point. If I do that, I cannot hear it anymore. Now I can. Yeah, and the stereo effect is working right from the start. That's nice. But I don't understand why I don't get that bit crusher effect, even though it's just like, you know, you should hear it even like something between this range, and between this range we can't hear it like without this crushing effect. Maybe there's some magic tick box somewhere. Enable attenuation debug. I don't know what that does. Enable bus sends, blah 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 blah. Okay, I guess I will leave it like that for Wednesday. I guess I won't be doing any audio on my own right now, because yeah, as I said at the beginning, there are some very important stuff that I should be taking care of, but they are not as maybe, yeah, the audio stuff is just more entertaining, I think. Something is bleeping and blooping, and you can see the difference or more like hear the difference immediately. Yeah, so I will doing that. Maybe I will record some stuff and yeah, use just those recorded samples inside to so we can already start implementing specific sound effects for our game, and yeah, test how this all works in a real usage scenario. And I will do Doppler effect just for Maciek. Okay, cool. I think that's it for today. Or maybe just one track of trombone champ at the end. I know you cannot wait. So yeah, let's do that. Thank you for great streamek. No problem. I love to do a streamek. I just got an achievement for muting sound. Yeah, I got some new trombone colors last time from boxes. Can I hear the difference? What's the difference between... Okay, let's try bass trombone, I guess. Alright. Yeah, let's go. Did you play Blood West? Not yet. I have so many games to play. Yesterday I was trying out... Sorry. The Midnight Club free dub edition remix on PlayStation 2, and I was shocked by how good this game is. I didn't play it since I was a kid, and like, man, this driving model in this game is so awesome. Like, if there's, I hate that in most racing games, if you hit something, it just feels like your car is a brick, just stops, or I don't know, blocks or something. Here is like very dynamic, very like springy. You just bounce off things, things bounce off you. Yeah, so I played some Midnight Club free dub edition remix lately, and I didn't have time for Blood West. Also, I started playing Metal Gear Solid 4, which is the only mainline Metal Gear Solid I did not play, so yeah, I'm hyped about this one too. Okay, let's do it. Another one. And yeah, that's it. Woo! But I think I prefer the normal trombone instead of bass one. It's cool, but no, it's lacking a bit in those higher frequencies. Let's go! Thank you, thank you. Ah, shit, almost an A. Yeah, let's open some boxes. Give me a sec. Tommy Dorsey, Blue-Eyed White Baboon, J.J. Johnson, J. Strauss. Why there are pentagrams on these cards? Like, is it just because I did... No, I don't know why. That's... okay, maybe... one box more, please. I need one on every single card of all 50. Ah, okay, so he changed his requirement now. Okay. I wonder if I can still trigger... Okay. So now I have to... But it won't be hard. You don't own this card. Ah. So only... I can make a card only if I already had it unlocked from the sack. Let's build this one. Okay, let's build this one. Okay, I can third this one. I hate music. Build this one. Yes, poop funny. Yes. Hot dog. Yeah, I hate my fuck. Hot dog. All duplicates. Build card. Okay, here I have some duplicates. Okay, I think I'm missing 3 cards, and yeah, there's no... I have just to play one more song. Maybe I'll just get those 3 I need. Okay, this guy. This one. Let's go. Ooh la la. Shit, almost 9. Okay, but we have enough money to buy a new sack. What's important. Design your own. Bass clef. JS back. Ooh, just 2 more left. Nice. Okay. Cool. So that was it. Thank you. Bye bye. See you next time.